So this is the use of Excel, and I see it as some essential skills in research. So you can use Excel, it's quite important for data entry and helping us understand statistical concepts. You can also use it for making a data sheet for your study. You can use it for saving data and keeping information, and you can save it as a CSV file, a comma separated value file. So let's look at what the spreadsheet looks like. We've got an area which is made up of cells or individual little squares. We have workshops labelled. Here in the corner here is A1. You can see that's a column A, row 1, B, column, row 1, and they all have an address. Also down the bottom you have a worksheet, and they're labelled sheet 1, 2, 3. You can rename those quite easily if you want to, and you can have colours on those tabs. So you can neatly enter your data in columns and rows, and you can have the labels at the top, which we also call a header row. So let's just see what you might typically have. In this small data set, we've got an ID variable, we've got a treatment variable in which we've got two treatments, an A and a B, and we have some variable names. I'm just calling it variable 1, and I'm also showing you that you can either use variable 1, you could call var 1, you could actually call it the weight. You don't want to have any spaces in those labels. You can then rename your worksheet as data. You can also have metadata and field plan, and that keeps all your data for your experiment in one Excel file, which needs to be backed up, of course. And you can see that it's neatly saved. You can save it as an Excel file, and you can also save it as a CSV file. Here I'm going to show you some data that's been entered. So I'm calling this data collected in this tab, and it's a small example just to demonstrate some methods of using Excel or looking at data or arranging data. And this, we have days absent of some workers. The item is the worker. And we're going to use it to just look at standard deviations, means, and the use of Excel commands, so you can learn a few things in one go. So this is how the data may have been collected, and it's put into rows. X is the variable, and in this case it's the days lost, the days absent over a 6-month period for that worker. So we've got 10 workers, items 1 to 10. What I've done here, I've now got it in a list, and so what I've now done is copied that data into here, and I'll show you how I did that. And here I've got the items, a column, which is the person, and I've got the X, which is the days absent, as you can see, and I've called this 2. What I'm going to do here is using a method to just show you what an actual mean and a standard deviation is. So here we have the data, which I've copied over. I'm just doing this for demonstration purposes. So you've got the data here, you've got the variable here, which is, we're just calling it X, and this column we're calling it the deviation from X. So X minus X bar, if you know anything about statistics, you'll know that X with a little line across the top is called X bar. It's used to call the mean. And how do we get the mean? We get our sum of X, which is the total of our X's, get the sum of our total number of items, which is 10, and we just divide one by the other. Got the 83, which is that, the N, which is the items, and then N minus 1 is our degrees of freedom for that sample. And we're going to show you here how to do the mean. Just move over to here, here's the mean, and if we click on that, you'd actually see that I've taken the 83 divided by the N, and so when I've got this column here of deviations, I'm actually taking my value of X, which here is 0, 0, etc., and taken off the mean. And then I've summed them. And surprisingly, hopefully you'll have some idea of this already from your previous understanding of statistics, the sum of the deviations from the mean are 0. Okay? So what do we need to do? We actually take, here we've got the sum of x bar squared. So we actually take the squared deviations from the mean, and here I've just got it here shown as x minus x bar squared. And you'll see that, for instance, minus 8 times minus 8 gives us 68.83. And I've summed those up. And so here's our sum of x deviations from the mean.